Hello, testing, testing. Audio settings. Okay, perfect. Welcome everyone. It's good to see you again. I hope you're doing well. Yesterday, we started solving a problem. This actually in the Seward textbooks when we're talking about of the problem number 42, the red one. And the problem established that we have a certain cable car in San Francisco can stop in 10 seconds when traveling at maximum speed. Okay. And one occasion, the driver sees a dog a distance D in front of the car and slams on the brakes instantaneously. The car reaches the dog 8 seconds later, and the dog jumps off the track just in time. If the car travels 4 meters beyond the position of the dog before coming stop, how far was the car from the dog? Okay, and actually the problem gave us a hint. You're supposed to need 3 equations. And let's see why we need 3 equations. Okay, what we have to do. The first thing that we must do in this kind of problems, because this is not so huge problem, but I strongly recommend to create a free body diagram of the situation with a picture of the problem. At the beginning, this is the cable car. This is the cable car. Now, you could imagine this is the cable car, all right? And this is the dog. This is a huge, a nice dog, okay? And according from the problem, at the beginning, the driver moves on some kind of initial velocity. We don't know what will be. We have no idea. Actually, and the separation between the car and the dog is a distance d, because the problem says when the driver of the cable car sees the dogs, it is slammed the brakes and moves on distance d, right? For that reason, the separation between the cable car and the dog is a d distance. Now, the dog moves just in time and the car slams the brakes until it reaches to the rest or stop completely the cable car. But it overpasses 4 meters, more than the original distance. For that reason, it increasing a distance of 4 meters, and the cable car will be located only on in this position, okay, when the final velocity of this cable car will be equal to 0. Okay, final velocity, 0. These sequences, we can identify 3 points, specifically 3 points. We have a point A, a beginning, in the middle, point B, and the last one, C. Remember, all the stops happens in the first 10 seconds. Okay, so this behavior between the point A until the point C passes around 10 seconds. And remember what the problem says. Okay, the problem says in the first 8 seconds of the movement, the cable car reaches the dog. For that reason, the period time between A until B, that will be 8 seconds, right? Why? Because the problem said, yeah, the 8 seconds, he saw the dog in distance D and slammed the brakes, okay? For that reason, if we know the total time between the point A and the point until the point C was 10 seconds, and the period time since the point A until the point B was 8 seconds, what will be the period of time since the point B until C? Will be 2 seconds, right? You don't need to calculate a physics formula because 10 minus 8, that will be 2 seconds. 2 seconds. This is going to be the distribution of the period of time. What is the breakpoint in this situation? The breakpoint will be the point C. Why? Because if you analyze the situation in the point B, this car has an initial velocity. If you want to compare with the final velocity in the point C, because the cable car comes to rest. But if you compare the cable car since the point A until the point B, this initial velocity will be the same final velocity if you want to compare Y perspective with the point 8. Okay, this initial velocity over here transforms in final velocity if you want to see the problem since the point A until the point B. Understood this part or no? Okay, excellent. Now, because we have this entire information, remember the problem asking for what will be that distance D. Okay, first of all, what kind of what thing we can make it between the point B and the point C, because as we said, this initial velocity, the point B versus the point C, will be the breakpoint. So we can perfectly find out that distance, sorry, that velocity. So if we analyze the situation in the point B until C, point BC, let's going to write the data available that we have. So we know the distance. What is the distance the cable car moves to BC? 4 meters. 4 meters. Okay. What is the period of time from the point B to until C? 2 seconds. Perfect. 2 seconds. All right. We know what is the value from the final velocity. That will be 0, because remember the cable car comes to rest at the point C when passes, the 10 seconds. And the missing variable or the unknown variable will be the initial velocity. All right. Remember, we have 4 equations to try of the variable velocity or problems on constant acceleration. Do you mind to tell me what could be the best option to use to try to find out the initial velocity? What of the 4 equations could be? The first one, right? Excellent. Why the first one? Because in the first one, we got distance equals final velocity plus initial velocity over 2 multiplying by the period of time. What is the value from distance? Okay, 4 meters. Open parenthesis, final velocity, 0. Plus initial velocity, we don't know. We have no idea. Over 2. Multiplying by period of time, 2 seconds. Yes or no? And actually, this number 2, that's divided passes to multiplying, right? So 4 times 2, we have 8 meters equals, 0 plus BO, that will be BO, no divide, because this is dividing passes to multiplying, and multiplying by 2 seconds, okay? And because this number 2 is multiplying, passes to divide, okay? So we have 8 meters divided by 2 seconds. So the initial velocity will be given by 4 meters. Excellent. And this is going to be the initial velocity in the point B until C. Understood under this part? Excellent. So we can see the beauty of the down in this problem because we have more information better than the beginning. Now let's going to analyze the point A, B, because the main objective of this problem is trying to looking for what will be the value from this letter D of this unknown variable. So if you wish, you can label the problem like a point AB. And let's going to write the data that we have available. For example, what is the initial velocity? No idea, because we cannot say the initial velocity will be 0. No, that's not possible because the driver was driving the cable wants some kind of velocity. Because at the beginning was at rest, there's no way you can hit the pure dog, that animal, that innocent animal. So we don't know what was the initial velocity of that gentleman. So initial velocity, no idea. Distance, no idea. This is what we're looking for. Period of time. What will be the period of time since the point A until B? 8 seconds, because the problem mentions the driver reaches the dog after 8 seconds. And what will be the final velocity located exactly at the point B? What will be? The 4 meters per second. That's why I'm telling you that 4 meters per second is the breakpoint, because this value from the point BC is useful for the point AB. That will be 4 meters per second. Okay, we have period of time, we have the final velocity. We don't know what is the velocity, and we don't know what will be the distance. If we have at least the value of the initial velocity, we can perfectly solve the problem using this equation, right? But we are screwed because at the beginning we don't have the distance, neither the initial velocity. So to see, yes, Norland, yeah. Because in this, just in this moment, remember, at this point, it's moving from distance D, and then this D separation, the driver slams the brakes and reaches the dog in exactly the 8 seconds. This dog is jumped, so the velocity was decreasing in this starting point at the 4 meters. Actually, remember when you slam the brakes, you won't stop instantaneously. The problem is you stop at the end of the 10 seconds and the driver moves 4 meters more beyond the problems. For that reason, the velocity to start in this point will be the same velocity before the stop, because you're reducing the velocity. Got it? Just like, for example, if you are located over here, I'm moving on, I'm reducing my velocity. The person who is located in front of me moves to the left or right side, and still, how to say that, continue my distance because I'm sleeping in the floor, so it reaches 4 meters more. But that reason in that point is the point when I reduce my velocity. That's why it's the same velocity in BC than AB, but it's changing by the perspective. For example, who's gonna be first, A or B? A, right? For that reason, B will be the final velocity. And if you see the problem between B and C, B will be the initial point and C will be the final. Yes. Say it again, please. No, the driver stops. No, the point B. The driver stops in the point C. Remember, because the problem says after at the end of the seconds, when the driver slams the brakes, it stops when it's moving beyond 4 meters. Remember what the problem says. Let me show you the picture of the exercise. Again, if you see, the car reaches the dog 8 seconds later. Remember, the full stop time is in 10 seconds. Remember, again, cable car can stop in 10 seconds. In the first 8 seconds, reaches the dog, but the dog jumps up. What does that mean? Exactly in this point B, it cannot be zero, the velocity. Just after the 4 meters beyond the position of the dog. Before what? Coming to stop. Okay, for that reason, the final velocity in C will be zero. Understood until this part? Lorna, did you understand why the final velocity over here will be the same initial velocity at this point? Okay, then. So to see the clearly done, we must try to looking for the initial velocity, because without initial velocity, there's no way we can calculate the distance. Well, but remember, what is the name of this kind of problems? We have variable velocity, right? And another way of saying when we have variable velocity happens when we have constant what? Acceleration. What does that mean, the constant acceleration? Constant acceleration, what does that mean? Will be the same. So if we have the value of this acceleration, we're going to see the dump. And how we can calculate the acceleration? If I'm using the point A, B, that's impossible because we have a lot of missing data by one hand. But by the other hand, if we take a look in the point C, BC, what information do we have? We have now the initial velocity. We know what is the final velocity. Yes, Lorna? Well, actually, the distance was useful to calculate the initial velocity we were using already. Now, in this case, we are looking for the acceleration because it doesn't matter if we have the acceleration in BC or AB because the acceleration is constant. Constant will be the same. It doesn't matter the spaces, right? So using the information from the point BC, remember we have the third formula, given by final velocity equals initial velocity plus acceleration and period of time. What is the final velocity in the point C? No. Final velocity in point C, 0. Initial velocity in point B, 4 meters per second, right? Acceleration, no idea, but the period of time, yes. And what will be the period of time between B and C? No, B and C, 2 seconds. Okay. Now, let's see what happened. This 4 meters per second is adding, passes to subtracting. Equals a parenthesis 2 seconds. And because this 2 is multiplying, passes to divide. Okay, so 4 divided by 2 will be 2. So we got the negative acceleration, 2 meters per second square. And that makes sense. Why they make sense that we have a negative acceleration? Because it's stopping, it's braking. And remember what did I say? Every time that we have a change of velocity for a bigger velocity is 4 meters per second. And another one is 0. To the smaller velocity, we are decelerating. We are braking the car. For that reason, the acceleration will be negative, yes? Why? Because in the point B and C, we have a lot of information to perform this equation. And remember the concept, constant acceleration means the acceleration will be the same, never change. Because remember the Kegel car since the beginning until the end is braking the car. So constant. Now that value will be useful right now to the point AB because will be the change. Sorry, but that will be the same. Okay, in simple merely words, That answer located over here, okay, I can use it in this value, negative 2 meters per second square. Now, what we're going to do, we can try to find out what will be the initial velocity. In which formula we can use to find out the initial velocity? If we have initial velocity, if we don't know the initial velocity, we know the time, final velocity, and acceleration. Obviously, Lorna, obviously this time the same, this one, right? Let's see. Final velocity equals initial velocity plus acceleration and time. What is the value from the final velocity over here? What is the value? 4 meters per second, right? 4 meters per second equals, we don't know what is the initial velocity, EO, plus, well, actually, what is the value of the acceleration? Negative. Negative times positive is negative, right? Negative 2 meters per second squared. And actually, the period time. What is the period time between the point A until B? 8 seconds, right? For that reason, let's see. 4 meters per second equals BO minus 2 times 8 will be 16. And remember, we can cancel 1 unit of the second, and we have 16 meters per second, right? Right? And 16, because it's subtracting, passes to adding. And we have 4 meters per second plus 16 meters per second equals initial velocity. And 4 plus 16 will be 20. So that makes sense. If you see at the beginning, obviously in the point A, the initial velocity that's supposed to be superior than the point B because it has a lot of the full speed at the beginning. And in the point B, the car is starting to slam the brakes, for the Samaritan speaking. Now we can find out the distance. To find out the distance, my dear student, we have 4 formulas. The 4 formulas, we can use 3 of them. If you wish, you can use this one. We can use the number 2 or the equation number 4. Which one would you like to use? All right, that one. So let's finish this. Distance equals final velocity plus initial velocity divided by 2, multiplying by time. So distance equals final velocity. What is the final velocity? 4 meters per second plus initial velocity. That will be 20 meters per second divided by 2, multiplied by, what will be the period of time? 8 seconds. So if you wish, 4 plus 20, 4 plus 20, 24 divided by 2, 24 divided by 2, 12, right? So D equals 12 meters per second multiplied by 8 seconds. And 12 multiplied by 8 will be 96. So, ladies and gentlemen, the cable cars driver at the beginning was a 96 meters from the poor and innocent dog. And, yep. Ah, pues sí, no quería matar al perrito. ¿Qué quiere? La Sociedad Protectora de Animales. Sí, María José. Por favor, muchachos, que no le escucho a ella, ¿sí? ¿En dónde? Aquí me dice usted. Claro, se cancela aquí y me queda 96, correcto, así es. Entonces, muchachos, para recapitular, Doy la explicación en español. El conductor del tranvía maneja cierta velocidad. Está escuchando Bad Bunny, Baby Rastra Ringo y no sé qué cosa. En lo que va a cierta separación, mira el pobre perrito. Entonces desde ahí mete los frenos y entonces según lo que dice el programa patina toda esa distancia y en los 8 segundos ya le pega al perro, lo alcanza. Pero el perro es vivo. Cuando mira el carro encima no se queda echadote, sino que se quita. Entonces una vez que se quita el carro en ese punto no para, sino que sigue patinando hasta que recorre 4 metros más. Entonces, me está diciendo el problema que desde el primer tramo hasta el último tramo pasaron 10 segundos a detenerse y 10 segundos antes tenía su máxima velocidad. Obvio, porque no había frenado. Entonces, el chiste del problema es tener la distribución. Si sabemos que del carro hasta el perro pasaron 8 segundos y el tiempo total es de 10 segundos, significa que el tiempo que tardó desde el punto donde estaba el perro hasta donde patinó los 4 metros, lógicamente solo se llevó 2 segundos, ¿cierto? Por simple proporción, como pudimos haber destacado. Por eso el problema decía, se necesita por lo menos 3 ecuaciones, use 2, use 3 ecuaciones, y de hecho, sí hicimos, en este caso usamos 2, pero pudimos haber usado otras si usted quería. Entonces, ¿para qué nos sirve este punto? En el punto B, obviamente el carro ha disminuido su velocidad, pero este punto B al punto C va a ser una velocidad inicial porque todavía no se ha detenido. En el punto C sí va a detenerse. Por lo tanto, al tener la velocidad inicial, tener el tiempo y la distancia, entonces nos permite a nosotros poder, poder calcular esa velocidad que había en el punto B, que es el punto de inflexión, donde de B a C es inicial y de A a B es el final. Y nos da 4 metros por segundo. Ahora, en el punto A, ¿qué nos daba? El tranvía tiene su máxima velocidad, que no lo sabíamos, otra cosa. La velocidad final que tiene el punto B, que no se ha detenido, ya averiguamos que era solamente 4 metros por segundo. Sabemos que se tardó en alcanzar el perro 8 segundos, pero no conocemos qué distancia. Ahora, el concepto que no debemos de olvidar en este tipo de problemas es que son movimientos de velocidad variable, o sea que cambia la velocidad, pero la aceleración es constante. O sea que no importa si usted lo agarra de A, B, C, D, E, F, G, H, I, J, K, la aceleración va a ser la misma en cualquier tramo, porque aquí solo estamos frenando. Por esa razón, como estrategia, no servía encontrar cuál fue la desaceleración o el freno que tuvo el tranvía en estos últimos 4 metros, porque últimamente es lo mismo. Al tener esta aceleración, nos permite conocer qué velocidad traía el tranvía antes de haber frenado, que lógicamente tiene que ser superior en el punto A que el punto B porque es la velocidad máxima. Y al conocer las velocidades, al conocer los tiempos y al conocer la aceleración, pues podemos encontrar esa distancia. Por lo tanto, muchachos, espero que les haya servido el problema, que les haya gustado. Dios los bendiga, los guarde y los cuide. Vamos a ver, vamos a hacer un espacio de eso. Dios los bendiga, los guarde, los cuide. Los veo el día de mañana. Esto es un problema nivel 3 de física, pero son los rojitos. Cuídense mucho, pásenlo bien.